Hello. So now I'm going to go ahead and go through the 2B portion of our review. All right, so let's see. Here they want us to solve, use square roots to solve each equation. So we need to get the x squareds by themselves. So we're going to subtract 49 from both sides. So we get x squared is equal to negative 49. Now to get rid of an x, or to get rid of the squared on the x, we're going to take the square root of both sides. When you add in a square root symbol, you also need to add in plus minus. So I get plus x is equal to plus minus the square root of negative 49. Now we learned that the square root of negative 1 is equal to I. So what we're going to do is we're going to break down the 49 into negative 1 times 49, and we know we can square root 49. The negative 1 comes out as an I. The 49 comes out as a 7. So we end up with plus minus 7i. So our answers are 7i and negative 7i. All right, here we're going to subtract 24 from both sides. We get that x squared is equal to negative 24. I square root both sides. I get that x is equal to plus minus the square root of negative 24. I got to break that down. I'm going to do negative 1. And then in this case, 24 is not a perfect square, so I'm going to use 4 and 6. So this comes out as an I. This comes out as a 2. And this stays in. So we get plus minus, x is equal to plus minus 2i root 6. All right. And then we're going to go ahead and simplify the square roots. Here we got to simplify square root of negative 72. I break that down into negative 1 times 36 times 2. I get 6, and I've got my root 2. So 6i root 2. Here, this just gives me a 5i. All right. Adding and subtracting complex numbers, it's just like combining like terms. So let's see, we end up with negative 12 plus 14i here. I's you essentially just treat as variables until they get powers. Once you get like an I squared or something higher than that, you need to kind of, you need to simplify it. All right, and we'll see that in one of these next problems here. I don't know. I'll do this one, I guess. So we're going to go ahead and distribute. So I get negative 6 plus 12i plus 3i minus 6i squared. I get negative 6 plus 15i minus 6 times negative 1. Oh, sorry. I didn't explain what I was doing. So, sorry, back up. This I squared, we know that the square root of negative 1 is equal to I. Now, if you were to square both of these, the square root goes away, and I get that negative 1 is equal to I squared. So whenever we have an I squared, we can simplify that with a negative 1. So now I got negative 6 plus 15i plus 6. And then I can combine like terms here, which actually these 6's cancel, so I am just left with 15i as my answer. All right. Let's see. Here we need to simplify. So basically you have to multiply the top and the bottom by the complex conjugate. So here I'm going to multiply the top and the bottom by 4 plus 3i. So let's see. On top, I get 12 plus 9i minus 8i minus 6i squared, which I end up with 12 plus I minus 6 times negative 1. So I combined these guys and got just an I. And then my negative 6i squared, my I squared gets replaced with a negative 1. So this ends up becoming a plus 6. So I get 12 plus 6, which is going to give me 18 plus I on top. And then on the bottom here, I get 16 plus 12i minus 12i minus 9i squared. These cancel, and I end up with 16 minus 9 times negative 1, which is not 16 plus 9, which gives me 25. So this would be my answer there. All right. So first off, writing something in standard form, that is just from highest power to lowest power. So I'll do this one. Standard form of this polynomial is going to be negative 3x to the fourth minus 8x cubed plus 2x plus 6. Now this like leading coefficient and degree. Actually, that'll come up in this. What I just opened up will come up in the next thing. Okay, so the degree is just the highest power. So this is going to be a degree 4. And the leading coefficient, that is the coefficient on the highest power. That's like the number attached to the variable. Our leading coefficient is a negative 3. Now, where this actually ends up coming into play here is when we're doing things like this, where we are determining the end behavior. All right, so to determine the degree, you're going to look at the highest power. So this is a degree 7. And my leading coefficient here is 3. Okay. So in this case, my leading coefficient is positive, and my degree is 7, which is odd. Now, polynomials, by their leading coefficient and their degree, you're able to tell their end behavior. Basically, this tells you, like, as you go off to negative infinity and as you go off to positive infinity, what happens to the function. If I were you, I would copy this chart down into your note card. And basically, by looking at the leading coefficient and the degree, here I have the end behavior, right? So since we have a positive leading coefficient and an odd degree, I got my end behavior here of as x goes to negative infinity, the function goes to negative infinity. And as x goes to positive infinity, the function goes to positive infinity. All right. Let's see. All right, this last little bit here. So there's a couple of different ways you can go about doing this. Honestly, what I would do is I would just go to Desmos. You guys are going to have Desmos on the final. So you could just go to Desmos, type this function in. So you got x cubed minus 2x squared minus 5x plus 6. And actually, you know, if you need to make a table, if you click this little gear symbol up top here, and then the table, it'll make a cute little table for you there. Let's see. And I do like the ones that we could probably put in some more points. 3, 4. Okay, great. So let's see. We'll do negative 2, 0, negative 1, 8, 0, 6, 1, 0, 2, negative 4, 3, 0, 4, 18, and I guess maybe I should have done 1 ahead of the negative 2, but whatever. We'll just do a 5, I guess. And we get 56, which is insane. Maybe I should have done like a negative 3, even though, well, no, that's actually going to be off the chart too, so doesn't matter. All right. So now we can sketch our graph here. Obviously, I guess I could have left this up to help with sketching the graph, I suppose. Plotting your zeros are going to be helpful. I also would like plot your y-intercepts. Let's see. We've got there. We've got 1 and we've got 3. All right. And this guy looks like this, kind of. And that's how you would sketch that graph. And then let's see, the zeros here. Our zeros are where the output is zeros. So we got negative 2, 1, and 3. So the number of turning points, that's kind of like these loop-de-loops. We've got 2 turning points here. And then the end behavior. So you have 2 options here. You could like use your cheat sheet, right, that I just showed you. And be like, okay, well, like this is our leading coefficient is 1 and it's an odd degree. So like we know this is the end behavior, and you could read your chart. Or you could think through it logically, like, okay, as x goes to negative infinity, what's happening to the function? Well, it's going down, so the function goes to negative infinity. As x goes to positive infinity, what's happening to the function? Well, the function's going up. We're going to positive infinity there.